Hey everyone, I'm VJ. I'm a software engineer at Drop, and today we'll be taking a deep dive into debugging. So before we start, I'll give you guys a little bit of background on what Drop is and what we do. So how many of you guys have ever heard of Drop or have used our app before? I'll put more hands than I thought. So we're a loyalty rewards program, and what users can do, you can link your card, debit card or credit card, and shop through your card or through the app, and you'll earn points for your shopping. You can redeem for different gift cards. So the entire app is pretty simple: shop, earn, redeem. And for our tech stack, our front end is React Native, JavaScript, TypeScript, and our back end is in Rails, and our infrastructure is in Kubernetes, Docker, and all on AWS. So a little bit of background on why I think debugging is an important topic. So when I first started coding in high school, I started in a computer science class, and I learned a little about recursion, some basic data structures, how to code, pretty much how do you solve problems. I went to university, more or less the same thing, except some algorithm analysis and a bunch of other formal things I never actually ever used in the real world. So naturally, after the 6-ish formal years of computer science education I never had one single lesson on how to debug. So naturally, as I joined the field, I was under the impression that most of my time will be spent just solving very clearly well-defined problems. But really fast I learned that most of my time was actually spent figuring out what problem to solve and not actually solving those problems. And one aspect of that is actually just debugging. So by the time I got into the field after maybe like 6-ish years of coding beforehand, I realized I didn't actually know how to debug well. I was always given this very well-defined problem, and then I went on and tried to do things. So over time, I built my own method to debugging, and I wanted to share that with you guys. So for today's agenda, we have 3 parts. So the first part is an overview for my method of debugging. The second part is a deep dive into some of those methods. And then the third part is debugging at scale. How do we take this process and actually apply it when your app gets very large? So I like to think of debugging in 4 separate phases, which is understand, reproduce, isolate, and correct. So the first phase is really about understanding your problem space, understanding what your product's meant to do, and what the bug really is. Without that domain knowledge, you can't really go about figuring out where the bug is. The second step is reproducing your bug. What is that set of preconditions that actually cause your bug? The third part is to isolate your bug. So what part of the code base does the bug actually originate from? And the fourth step is actually just correcting the bug. So staying with the theme of figuring out what problem to solve, most of this presentation will actually only focus on the first 3 steps, which is understanding, reproducing, and isolating the bug. Actually correcting the bug really depends on the nature of the bug and what type of methodologies and patterns your team decides to use. So I'll focus mainly on the first 3 steps. So the next part is, let's take a deep dive into those first 3 steps. So the first step is actually understanding the bug. So as soon as you have a bug, the first thing you should try to do is answer 4 questions, which is, what was the product designed to do? What were the steps the user took? What did the user expect? And what did the user see? So the reason these questions are very important is all these questions really help you in the next few steps of the bug. So for example, if your product manager brings a bug to you and you don't understand some of these questions, you might be solving a bug that doesn't need to be solved. For example, if your product is not designed to do a specific thing, then this is really not a bug you should be solving. That should be a feature request, not a bug. And the next 3 questions out of that will really just help you narrow down where in the code base the bug is, and then gives you an idea of what to look for when you start looking at the code. And in the best case scenario, you won't need to fix the bug at all, and you can find a non-coding way of solving the problem. So the first tip, avoid using documentation as your main mode of communication. So documents are really useful and very powerful for sharing knowledge, but it's not a good method of communicating. So from the image you can see above, this is a cake that says thanks for a great year in purple. So this is an extreme example, but I think it pretty much displays the point pretty well, which is someone gave a document to someone and they followed the steps, and it was up to a certain amount of ambiguity, and then they couldn't have that conversation to actually clear up any clarifications. That's why you should always prioritize a conversation with your stakeholders over simply passing a document over. In the case where documents your only method of communication, you should really be disciplined about what information you require in document. And the second step, which is reproducing your bug. So in the first step, you understood in product terms what did the user do and what did the user see. You want to translate that into what was the state of the program before the bug occurred. So if you think about debugging is really just a series of search problems. The first search problem you're doing is what are those inputs that actually lead to this first bug. So for this second tip is you want to automate the reproduction of your bug. So oftentimes, I fell into this when I first started as well, is as soon as I actually reproduced the bug, I never actually automated it. So I'd have to go through a whole bunch of loops just to figure out, to reproduce the bug over and over again. And actually automating your bug will help with the next, automating the reproduction of your bug will actually help you a lot in the next few steps. So there's a few different ways you can do this. If you're a server-side engineer and then you know that this bug happened when you hit an endpoint, you can simply just use Postman and then that will be essentially automation. If you want to go a little bit further than that and use like a TD type of methodology, you can write integration tests. Or you can just write a script and then run it in the console. So for example, if I ever did front-end debugging, I knew that a series of events in React would reproduce the bug, I'll write a script that just dispatches that events in order and then I'll just run it in my console. So the third step is isolating the bug. So this part is really about simplifying your problem. So in the first two steps, you broke down the problem from here are all the user inputs, and this is the output they got. But then, depending on the nature of your problem, you'll have a lot of different inputs. So what version of iOS is the user on? What version of the app is the user on? A lot of different inputs. So actually isolating it to a certain part of the code base will simplify this for you to potentially even a single method. So the single method has one output or one or two inputs and a single output, which is a lot easier to work with than lots of different types of inputs. And then this step, depending on the way you handle the first steps, should be pretty straightforward. In the worst case scenario, you can just pull out your favorite debugger and just step through the code all the way down. And this is the third tip. So this is a tip that I overlooked a lot when I first started, at least, is actually keeping a debug log. So for most simple bugs, you can keep everything in your head and know exactly what's going on. But when a bug is a little more complex, there's too much going on to actually keep everything in your head. So just writing it down actually is like a simple way of rubber ducking to yourself. So just actually writing out the problem helps you actually think through the problem better. And the worst case scenario, say you need to debug the next day, you can use all that knowledge that you wrote down the day before and just read that right before you start, just to leave off where you left. And in summary, so the process is pretty simple for the most part. It's understand, reproduce, isolate, and correct. And the three main tips would be avoid documentation as a mode of communication. Be sure to write things down and automate your reproduction of your bug. So debugging at scale. So this process seems pretty simple for the most part, but how do we actually use this in practice when your app actually gets large at scale? So the amount of inputs you have on a small app is pretty small. So if we think back to the analogy I said earlier about debugging really being a search problem, you can illustrate it with a graph. So if I imagine what debugging is, it's really just a search problem, and I can represent any search problem as a graph. And me debugging and going through the step will just look like this. Me just traveling through the graph until I find the source of my bug. And this works really fine in a small graph, but in actuality in a production app, your graph is going to look something like this. So this is actually a real service map of our code base, just the backend specifically, that we got from Datadog. So trying to do all those steps manually in this graph would be almost impossible. So actually trying to solve this way won't work. So how do we use tools to actually help this be a lot easier? So we use a bunch of different tools, but four of the ones I want to focus on specifically are Pry, which is our debugger, LogDNA, which is our log management tool, Sentry, which is the error monitoring platform, and Datadog, which is used for APM metrics and monitoring. So the first tool is Pry. So Pry is the de facto debugger for the Ruby community, and in my opinion, it's probably the best debugger I've ever used. Hopefully, most other technology communities have a debugger that's similar. So it gives you all the basic things like breakpoints, source code browsing, things like that. But in addition to that, it gives you a lot of customizability into what you do when you debug. So for example, you can navigate around state. So you can treat every object as a file, for example, and you can jump into different objects to actually view their state. You can actually also change code live during your breakpoints if you want to test out some of your solutions as well. So the second tool we use is LogDNA, and I think, in my opinion, if I were to make a production app, LogDNA would be the first tool I would actually implement, or like some sort of logging system in general, to actually compile your logs. So what log management really lets you do, if you refer back to the process, it automates isolation of your bug. So you can compile a bunch of logs, send it to LogDNA, and LogDNA makes it really easy for you to query and actually put all your logs together in a simple format. So I'll give you some tips on how to make log management a little bit easier. So the first thing here is I have a code snippet right here from our code base. I did my best to actually add some abstraction to make it practically pseudocode. And then one thing I'll mention is that unless keyword, you can just, if you're not aware of Ruby, that just means if not. It's just something specific to Ruby. So this is one piece of the code base where different users on the app looking at different offers. So if you ever see that recommended for you section, we do this thing called offer assignment where we assign different offers to different users based on how relevant that offer is. So this is one piece of code that actually runs when we're deciding to assign an offer to a user. So I use logging here to make it a lot easier to debug. So an example is the first thing I did here is I used what we call MDC, which is our map diagnostic context. And what the map diagnostic context is, it lets you inject more diagnostic information into your log in addition to just your logging message. So for example, at the very first line, I push the offer ID and the user ID into the MVC. So I can actually go back to LogDNA and search by this specifically. And then the second thing I use is logging levels. So in this specific example, all my logs are in the debugging context. If this is a little bit noisy, I can actually reduce the logging level. So I can change it to a warning level, I can change it to an error level. And when I'm searching my logs on LogDNA, I can choose to what granularity of logging I really have. And the second part, which is not specific to any language, is really just following the single responsibility principle and breaking my code into sections so I can log in an easier way. So in the first part, I broke it up into checking if the offer is active. The second is checking whether the offer is relevant to the user. And the third one is checking if the user already has the offer. So just following the single responsibility principle makes it easy for me to just log separate parts. And then in a real world example, let's say someone comes to me and says, this user X is not receiving offer Y. It'll be very easy to debug this. I'll just go back to LogDNA, search by mdc.userid is X, offer ID is Y, and all of these logs will appear. And whichever log doesn't appear will tell me what part of the code base to actually look at. So the second tool here that I'll talk about is Sentry. So Sentry is just an error monitoring system, and it's also open source. So it's one problem to actually have bugs in your code base. There's an even bigger problem if you don't know there's bugs in your code base, and that's what Sentry is really for. It gives you visibility into whether you have bugs, and also gives you some diagnostic information to know where to start. So Sentry is really powerful. So in this example here, it tells us how many events of a specific error we get over time. So I can actually figure out how big of a problem this bug is. If you're a larger organization, it gives you even better info. So you can do location heat maps to show this area, this region is facing a lot more bugs than some other region, which might tell you that you might have some sort of infrastructure issue. And then Sentry also gives you a lot of customizability, so you can send custom errors to Sentry as well. So one thing we do at Drop specifically is we have a lot of different API integrations, and they can break for a whole slew of reasons. So one thing we do is we send custom errors to Sentry, and we can configure it to hit a Slack channel specifically, and in real time, I'll know when the error occurs. So for example, if the customer success team does some sort of process in the backend, and then there's an error, I'll know right away because it hits my points updates channel. And that points updates is just a channel specifically for the points team at Draw. And the third tool, which is my favorite tool, is Datadog. So Datadog is the most powerful of the three tools. We use it for APM metrics and monitoring specifically. So these two images are actually just taken from Datadog site specifically, but it's a good example of how you can actually use Datadog. So on my left side, which is your right side, there's a monitor there, and you can automate that to when you have a specific metric hit a certain threshold, you can get that to alert you. So by email, through Slack, through PagerDuty if you use that service as well. And on the left side, you have more granular information. So once you hit a monitor, I want more information about what's causing this issue. I can go into Datadog and see all that information. So here's one example of the way we use Datadog. So we have a lot of affiliate integrations. So when a user clicks through a link and shops at a third-party site, how do we know that they actually shop there? The way it works is our third parties would build into different affiliates, and that affiliate will send us an event back saying user X shopped at brand X and they bought these things. And then using that information, we'll award you some points. But the affiliate integration space is pretty fragmented, and there's a lot of different affiliate integrations that we have to support. So for example, here we have five of them, and we have different monitors on how many points are we giving out at any time, how many events are we receiving. So one example was one day, I think back in February, Rakuten just stopped sending us events. And we actually had no idea why. And we knew right away because the monitor alerted us that we received no events in 24 hours, which is very abnormal. So afterwards we investigated, we found out that someone on our BD team had actually changed their credential, which invalidated our credential in the backend, and that's why we stopped receiving events. But the monitors made it so we knew right away. So in the worst case scenario, if we didn't have a monitor, we probably, maybe the finance team who's doing revenue reports sees we're not making money from any offers, why not? And that's 30 days after we actually had this issue. This monitor alerted us of this issue right away, within hours rather than 30 days. And a second use case is actually when you're debugging performance issues in the backend. So this is an endpoint we had called categories. So as soon as you open that, you hit the categories endpoint, which compiles a bunch of offers to you based on relevancy. And we noticed that the app was very slow on Bootstrap, and we used Datadog to figure out what part of that endpoint was causing the performance issue. So Datadog gives you pretty specific information about what part of the code base is actually taking a lot of time. So if here, for example, in this bottom right side, it tells us with pretty good granularity what part of the code is taking the most amount of time. So here, that blue spot, which is our category rendering service, which is our serialization, was taking a lot of time. And then we dug into that more, and we found out that we had a few query issues, and we optimized those queries, and we fixed the problem. So here's a quick summary of the way our architecture works. So as a client makes requests to our Rails application in our Docker container, we have Prime set up straight onto the Rails container. This is not actually in production, we only have it on dev. But the architecture diagram works more or less the same way. And then as code runs, we pass information to Datadog, LogDNA, and Sentry. So one thing you might ask is like, how do we take this to the next level and make this even better? So one thing we actually do at Drop is we use this thing called a correlation ID, which lets us link the entire life cycle of a request and everything that happened between then and through all our services. So we generate this correlation ID at the very entry point of our system, and we generate, it's just a UUID that will be unique, and we pass this along to all our services. So we can pass this to Datadog, Sentry, LogDNA. We also pass it to the front end, our database. So we can, when we see an issue, we can use that correlation ID to link a bunch of information all together. So I'll show you guys an example. So here we have the Sentry error, and I want to debug it further. I just grab this correlation ID, I go into LogDNA, I can dump that correlation ID in it, and then it'll give me the life cycle of all the logs that happen with that ID. So this is very powerful because it lets you see the logs of not just one service, but multiple services. So for example, if the front end is also logging to LogDNA as well as the back end, the correlation ID will link all those logs together. So I can see the life cycle from the back end generated correlation ID, what happened in the back end. I pass this correlation to the front end continues passing that along, and I get to see like the entire user behavior front to back. And this is really powerful. So like say for this example, I also want to see, oh, why is this endpoint taking long? I can take that correlation ID and dump it to Datadog as well. And as we expand and become more microservice oriented, correlation ID will really help us scale. So as a quick summary, we use Datadog for APM metrics and monitoring, LogDNA for log management. We use Sentry for error monitoring, and Pry as our debugger. And then we use this correlation ID to link all those services together. So approaching the end of the presentation, I'll do a quick summary of what we went over. So the first part is how do we go from only using intuition to debugging to actually having a process, which is the first step there. You go through the process of understanding, reproducing, isolating, and correcting the bug. And once you're in an actual production level app, you can use tools like Pry, LogDNA, Sentry, and Datadog to actually take you to the next level and automate a lot of those steps you were doing earlier. So now when you have a graph like this, you're automating all that information gathering, and then you can get to this. So, and I guess I'll leave room for questions. Cool.
Sure, it's a really basic question. What are APM metrics?
Oh, APM is application performance metrics. Sorry, I should have mentioned that earlier.
So you made this point about don't use documentation for something. Well, what's the alternative? What are you comparing that to as a,
So documentation is not necessarily bad. It just shouldn't be your go-to mode of communication. I understand that in some situations, documentation is the only way of doing it. But if you have the option of not using documentation, you ought to use the alternative, which is just having a conversation, whether that's over Slack or in person. But there are cases where you have to use documentation. It's just not ideal. Does that answer your question?
well, I don't feel it's answered satisfactorily because so many problems are so complex that a conversation isn't going to hack it because you won't remember enough details or whatever, right?
Yeah, so the point I'm trying to make is like actually not to avoid documentation altogether. So documentation should just be a record of a conversation, not be the conversation. Yeah.
You should not confuse documentation with specification.
How do you set up those charts on Datadog? Are those like, do you get those for free or are you configuring
Yeah,
those?
so you can configure them, so you can send different metrics to Datadog specifically. And based on, you can go into Datadog and say, like say, when my ALB response time hits above 1 second, I want to be alerted of that.
But how does it know your ALB response?
So you can configure AWS to send it to a Datadog. And any type of metrics I send to Datadog, I have to configure my system to do that.
What kind of tools do you use to automate bugs in React Native?
So on the front end, the main one we use
Couldn't hear the question.
Oh, sorry. So the question he asked was, what type of tools do we use on the front end with React Native? So the main tools we use for the debugger, we use the React Native debugger. But in addition to that, we also can use LogDNA there. We use Sentry as well for error monitoring. And then React Native also has the mobile apps in general have their own set of tools as well that you can use, like for example, like UXCam and web apps specifically have like LogRocket, and those are different tools that you can use on the front end as well.
So when you look at the tools like Pry and Datadog and all that, how do you compare them with something like Splunk, which I feel kind of offers a consolidated view of all of these?
Yeah, so
comparable?
for us specifically, so the tool itself is probably not the actual important part. It's actually just having what the tool does. So if one day there is a tool that does all this, we would use that, for example. The reason we didn't use Splunk is the pricing package is actually a lot more expensive than just using them separately. So that's why we didn't use Splunk specifically.
So is this pattern of using a correlation ID something you guys came up with, or is it kind of an established pattern out there?
So for most companies who use like more microservices architecture, it's actually pretty common. This is something that Darren, our CTO, actually took with him from Eventbrite. So he was an engineer at Eventbrite for a few years, and they used this in their microservice architecture. So as soon as he came to drop and created the app, essentially he implemented this as soon as he could.
So, I mean, ultimately, when you have a lot of defects, right, like eventually you want to take your application into a state where you you're preventing these problems, right?
Yeah.
It's not like we're playing a game with defects and fixes and stuff. So if we can, so do you use any tool to analyze these recurring problems and help us come up with a resolution to actually prevent the problem? Does these tools help you with it?
So the tools in of itself, I wouldn't say actually prevent the bugs. It's mostly just lets you know as soon as there is a bug and how do you fix it once it's there. Preventing the bug really depends on the patterns of your code base, I would say, and then how much time you're taking into actually investing in the quality of your code. So if you're always rushing to just implement things as soon as you can without really worrying about the quality, you will have bugs over time. None of these tools prevent bugs, they just help you know when there are.
Is there such a thing as sending too much information in a log?
So there can be, but as long as you use your debugging level as well, it shouldn't be a problem. So the most high level information you can send your debugging level, but then if you want more specific information, you use different logging levels like warn and error. So say for example, I only want to see errors, I can just click error on log DNA and I'll only see that level of granularity. Log DNA error.
Yeah, using these tools. Accuracy. Or is it always 100% accuracy?
It wouldn't be 100% accurate per se. So for example, you could have defects in your code that don't actually have any errors related to them. It could just be the code is outputting the wrong thing, and you wouldn't have an error. So Sentry only actually monitors errors that are thrown. So these type of tools don't have 100% accuracy found finding every bug. Question back.
So, in terms of debugging security issues, security bugs, is this presentation kind of focused on functionality? In terms of security, would the process be the same as the first question? Those kind of four boxes that we developed on. And the second question is, do you guys use Veracode or Qualys, or what tools do you use for security debugging?
So most of our security debugging, because we're on AWS provides a bunch of tools for us. So for security debugging specifically, we use like a CloudWatch. Also, some of the tools we use here specifically actually help us with security debugging. So for example, if the sessions endpoint is getting hit with thousands of requests in some specific time, we can reasonably assume that someone's trying to log into someone else's account. So we can use Datadog monitoring to actually automate all that. And then for debugging security issues, we use more or less the same tools, plus the tools that AWS gives us, which is like CloudWatch, and probably a few other services provide this as well. Did that answer your question, or?
But the process is the same, or?
Yeah, the process is exactly the same. You're really trying to isolate the bug to where it's happening. The only difference would be is a lot of these security issues may not be a result of application code. It might be just inadequate infrastructure. But then actually isolating the bug would be similar.
The thing is, the problem I have with that AWS is that AWS, what if my stuff sits on-prem, right? So what do I do then? What's the recommendation there?
Pardon? Can you repeat that?
What if my stuff sits on-prem, right? If my infrastructure is on-prem, not on Azure or AWS, any recommendation there in terms of security tools in debugging?
So in terms of tools for those environments, I'm not exactly sure, but I'm sure, for example, like Azure or Google Cloud would have similar tools. If not, you'd actually have to build it yourself or try to find a software as a service solution. It probably doesn't answer your question exactly.
Sorry, I'm not like trying to litigate here, I'm just trying to kind of get to the bottom of this. So for example, our workbench, we use Veracode, we use Qualys. Half of our stuff sits on-prem, the other half on some, I can't name the provider, but whatever, the provider. Now I'm trying to get my head around it. So for example, I'm getting a report, 70 pages from the security team, from Qualys or Veracode or whatever tool is there. And it gives me like 400 errors, right? So what do I do with that? Like when you're a developer, say you're a developer, like I come to you, what tools would you use?
So given my code base, I'll use exactly the tools here. For example, first I'll dig into the documentation to see like where does that bug actually start, and then I'll try to isolate it. I probably don't have enough information to answer your question. You can probably, you can take us offline and
All right.
ask further.
Thank you.
Thank you, BK.